Okay, let's start my presentation. Today, I would like to talk about applied LCA approach to analyze the environmental effect of China's solar photovoltaic industry during 2011 to 2016. My name is Bo Yu, and I'm studying civil engineering at UNSW. My presentation will take about 5 minutes and divided into 4 sections. Okay, so I will briefly summarize the main issues. I want to begin by report's background and identify how it's related to environmental sustainability, and then I will move on methodology, focus on explain why the tool was chosen. Next, we are talking about results, and finally, we will land on conclusion and limitation. Okay, let me begin by giving you some background information about the environmental issue. There are 3 main reasons for this part. My first point concerns government roles. The government makes a great effort to push forward power sector market reform and improve the company's management mechanism. In government incentives, China has provided several solar PV products to the world market at more affordable prices. The profit is used to enhance the rate of domestic installation and deployment of solar PV power. That's the second point. In addition, along with the increasing concerns of climate change, solar PV power as clean energy technology has seen dramatically growth worldwide. Hard and Gibbs indicate that a PV power generation could consume more fossil energy compared with the coal-fired. Based on above background information, I would like to move on to second part of the presentation, methodology. So what is the LCA? The LCA approach is used as a tool to evaluate the environmental effects of a product, process, or activity throughout its life cycle, starting from the use of raw materials to process, transport, and disposal. Significantly, if you look at this graph, you will see the LCA study in this paper covers all 11 stages of the industry life cycle. From this chart, we can understand that the environmental cost of the solar PV industry considered in this study consisted of 2 parts, domestic and export. Meanwhile, from this line, it shows that the growth of the cost had largely been attributed to export growth. From both slide charts, the improvement to the solar PV industry environmental effort in China during 2015 to 2016 are mainly attributed to the dramatic growth of the domestic installation and deployment. Okay, in summary, as I said before, this paper examined China's solar PV industry environmental cost and the benefits for 2011 to 2016. The LCA approach is used in quantify results. The building on the above results, it can be concluded that the scaling up domestic deployment of solar PV power is beneficial to environmental economics. However, there's many possible limitations of LCA that we may have faced. Firstly, LCA study depend on assumptions and scenarios. The scenarios, assumption, and the scope may vary from one study to another, leading to different LCA results. In addition, performing LCA study is reference consuming, mainly due to the large amount of data needed. If data collection is poor, the study will not lead to solid conclusions. And finally, it is not easy to communicate the result of an LCA study. For example, product A may not always perform better than product B, but only on certain impacts. A more detailed analysis is then needed to explain the difference and highlight both products' benefits and drawbacks. It can be difficult for decision makers to choose from. Okay, so let's bring me to the end of my presentation. This is my reference. Thank you for listening.